Okay, it says we're recording. Okay, so go ahead and ask your question, Lauren.
I was just wondering if the tests are multiple choice or if they're how we've done them before, where like they're written out. I was just wondering
Yeah.
like what the format is.
So the math department has a very strict policy of no multiple choice tests. They don't have that for quizzes, so that's why I did it on the quizzes. So yeah, the tests will be exactly the same as we've done in the past. I think on Friday, I'm actually going to watch the videos to find out more. So I'll have more information. But basically, yeah, just as we've done before, we'll have 10 questions. Probably what's going to happen is we're going to use Proctorio. So you'll need a computer with a web camera. You will take a picture of your test with your phone, or if you want to scan it in, it will look better. But you'll take a picture. There'll be some instructions, and I think I'll probably have like a practice Proctorio quiz. I think they have one. I haven't looked at it yet, but I'll probably have you do that Monday or Tuesday so that we can make sure that everybody knows how to use Proctorio, including me. Yeah, it'll be 10 questions just like normal. It'll be just like all the other tests. And so yeah, it won't be really any different other than you'll take pictures of your tests and you'll upload those to Canvas, and then I will grade those, which I'm really looking forward to that. But anyway, we'll see how it goes.
Will it be like from 12 to 1? Like we have to do it within that time?
Yeah, basically.
Yeah.
I will probably, because I know that people might struggle with technology a little bit, I'll probably give you maybe 90 minutes rather than 60, just to make sure you get your test loaded. But yeah, that's basically what I'm planning on. So 12 to 1, or maybe I might even go to 1:30 if that helps, because I just don't want to have any technology problems, and so I'll probably give it a little bit more time. But it will be needed to be uploaded by then. So good question.
Okay, thank you.
Mm-hmm. Any other questions? All right. Well, Landon just missed that great question about the test, but you'll have to watch the video. That was a good question. So, all right. So if there's no other questions, I'm going to go ahead and we're going to start on section 6.3, which is on inverse matrices. So 6.3, inverse matrices. Now, this is probably going to be a lot harder than yesterday's lecture. I'll just give you a fair warning here. And in fact, remember when we were talking about the Gauss-Jordan and I said that it was going to come back and haunt you if you didn't learn it? Today is Halloween. So anyway, we'll start with something easy though. We've got what's called the identity matrix. The identity matrix. Okay. And basically what that is it's a square matrix with ones on the diagonals, and zeros everywhere else. Okay? So basically what that means, so a lot of times we'll represent I2, which is going to be a square matrix. It's going to have ones on the diagonals and zeros everywhere else. And so that would be the identity matrix for a 2x2. Okay. We also have I3, which would be ones on the diagonals and zeros everywhere else. So that would be a 3x3 matrix. That's why we have the I3, and zeros everywhere else. Now, by the way, I don't think Cameron is here. and he was my tech guy. Do you guys remember? I know that, especially when we watch this on video, that I'm only a quarter of the screen. How do you make it full screen for people who are live? Do you guys remember how to do that?
If you go to the three little dots, it gives you the option to enter full screen.
Enter full screen, and so then that will do full screen when I'm on.
Mm-hmm.
Okay, so you guys can go ahead and do that. It won't do me any good, but you guys will have to do that individually. So it doesn't help for the video if you're watching this later, but it does help for people that are here live. So, all right. Okay, so the last thing I wanted to just mention was I4. If we're doing a 4x4 matrix, you've got ones on the diagonals and zeros everywhere else. Okay, so that would be your 4x4 identity matrix. Okay, and so you're going to find that these identity matrices have a really cool property. So if I were to take the I2 matrix, identity 2, so 1, 0, 0, 1, and I wanted to multiply that by another matrix, which would be 3, 5, 6, -1, 2, and 7. Okay. So, Joey, do you still have crappy video?
Yeah, I do. I downloaded the app. So it's a little clearer.
Okay.
Can you hear me?
Yeah, I can hear you. So, can you see what I've written here on my page, or is it too fuzzy to see?
Is it 1, 1, 0, 3, 5, 6, and then 0, 3?
0, 1,
Below
and
the,
-1,
oh, no,
2,
0, 1.
7.
Okay.
Yeah. Okay, well,
Okay.
we're gonna try this and see how good you do. Okay, so I want you to multiply these two matrices together. So do you know how? So first of all, the first question is it possible to multiply these two together?
Yes, because
Yes.
it's a 2 by 2, and then it's a 2 by 3, so the 2's are the same.
Right. So the twos are the
Right, the
same.
inside 2's.
The inside twos are the same, and so my matrix will be what dimensions?
2 by 2.
2 by
Or
3. It's the outside
2 by
numbers.
3. Oh, okay.
2 by 3.
2 by 3.
So it's going to have 2 rows. It's going to have 3 columns. Okay. So I won't make you do the whole thing, but let's try the first row times the first column. Can you help me do that?
Sure. So I'm not 100% sure how to do it. Is it the 1 times 3, and then 1 times -1, and then zeros?
Right. Correct.
Okay.
So 1 times 3 is
1.
no, it's
I mean, sorry, 3. Sorry, 3.
Okay. And then 0 times -1
is 0.
Is 0. So 3 plus 0. Okay. Now we're going to do the first row times the second column. So 1 times 5.
5.
0 times 2.
0 times 2, 0.
Okay. And then we're going to do the first row times the third column. 1 times 6.
6.
0 times 7.
0.
Okay, we'll have somebody else do the bottom row. How about Nicole? Can you hear me? You need to unmute yourself if you can hear me. I know I tried to talk to her before and she didn't hear me, so I don't know. Let's go to Riley. Riley, can you help me?
Yes, is it the 0 times
Yeah, the bottom
3?
row. Maybe I should use a different color. Okay, so 0 times 3 is?
0.
1 times -1.
-1.
Okay, and then 0 times the second column. So 0 times 5?
0.
and 1 times 2,
or 2.
2. 0 times 6,
0,
1 times 7,
7,
7. So we'll add these. So this becomes, I'm going to write it over here, 3, 5, 6, -1, 2, 7. So what do you notice about the answer and this matrix?
It's the same thing.
The same thing. Okay, so that's what's special about the identity matrix is you can think of this as multiplying by 1. Okay, so the identity matrix is the matrix version of the number 1. Okay, now that's going to become helpful to us very shortly. So let's talk about the inverse of a matrix. So inverse of a matrix. Okay, so if I have a matrix A and I multiply it by the inverse of matrix A, so that looks like A raised to the -1 power. Okay, that's how we would identify that. The nice thing about that, it is commutative, so I can do A inverse times A. Those are equal. But when you take a matrix and you multiply it by its inverse, you get the identity, and I'll use the identity matrix. So I'll use I sub n for whichever. So if you're using a 2 by 2, it would be I2, a 3 by 3, it would be I3, etc. So, and of course, you don't need to necessarily multiply the identity matrix by, it doesn't have to be a square matrix as we just showed. It works out that way. So that's pretty cool. Okay, so let's do another example here. If I have a matrix A, which equals 2, 1, and 5, 3, and I have a matrix B, which equals 3, -1, -5, and 2. Okay, let's pick on, let's see here, Andrew. Andrew, can you help me multiply these two together? What we're going to do is we're going to see if these are inverse matrices. Okay, so how do I do that? First of all, before you do that, is it possible to multiply these two together?
Yes.
Yes, because?
Is it the fact that it's 2 by 2 and 2 by 2?
2 by 2, and so my resulting matrix will be?
2 by 2.
2 by 2. So I'm going to just put blanks here so I know we've got a 2 by 2 coming up. Okay? So we're going to take the first row times the first column. So 2 times 3 is?
6.
6. 1 times -5
is -5.
-5. Okay, then we're going to do the first row times the second column. Okay, 2 times -1
is -2.
-2. 1 times 2
is 2.
Plus 2. Then we're going to do the second row times the first column. 5 times 3
is 15.
15. 3 times -5
-15.
-15. And 5 times -1
is -5.
-5. 3 times 2
6.
is 6. So when we simplify this, 6 minus 5 is?
1.
1. -2 plus 2?
0.
0. 15 minus 15?
0.
0. -5 plus 6?
1.
1. Okay, so I have the identity matrix. Okay, so therefore these two matrices here are, so A, this is really A times A inverse. A and B are actually inverse matrices. Oh, sorry, I'm off the screen. Okay, so A and B are inverse matrices, so I could really write this as A inverse. Okay, making sense so far?
Yeah.
Okay. All right, so let's move on we are going to show you how to find find the inverse matrix. Boy, this is terrible handwriting, I'm sorry. Find the inverse matrix, okay? Now, there are actually two methods. There's an easy method and there's a hard method, okay? Now the easy method only works on a 2x2, and I will show you that in a few minutes. But I want to show you the hard method first. And the fact of the matter is, you need to know the hard method for a 3x3 because there is no other way to do. There is no easy way for a 3x3. So we're going to start with a 2x2. So if I have an inverse A, which equals 4, 5, 2, and 3, and I want to find the inverse matrix, okay? Now you notice I didn't finish that off. So this is the hard method, but it's the only method for a 3x3, okay? So what I'm going to do is I'm going to put a little dashed line here, okay? And I'm going to put the identity matrix 1, 0, 0, 1 next to it, okay? Now, the goal is to make the matrix on the left look like the identity matrix. And so this would be 1, 0, 0, 1. When we do that, it's going to be, then what's on the right will be the inverse matrix of what's on the left. Okay. And so essentially what I've got to do is I've got to turn that 4 into a 1 somehow. So how could I do that? And this is going to have fractions in it. I really wish I should have picked a better problem. But sometimes you're going to get fractions and it's going to be ugly. So anyway, say that again. Somebody's piped in and I interrupted.
Divided by 4, maybe.
Okay, so rather than divide, we would multiply by a fourth. Okay, so 1/4 of row 1, and we're going to put the result in row 1. Okay, so that's going to give me, so if I basically divide by 4, like you said, or 1/4, okay, that's going to give me 1, 5/4, 1/4, and 0. Okay, so now I've got a 1 here. Now I need to get a 0 here, and I'm going to use this row here. So what's the easiest way to get that 2 to become a 0 using our new row 1?
Times it by -2.
All right, so exactly right. So -2 times row 1 plus row 2. We're going to put the result in row 2. Okay, so I'm going to put a -2 here just to help me. So -2 plus 2 is 0. -2 times 5/4 is -10/4. -10/4 is the same thing as -5/2, which is also -2.5. So 3 minus 2.5 is 1/2. Okay. -2 times 1/4 is -2/4, which is -1/2. -1/2 plus 0 is -1/2. And -2 times 0 is 0. 0 plus 1 is 1. Okay? Making sense so far? Okay. All right, so now we need to turn this 1/2 into a 1. What's the easiest way to turn that into 1?
Multiply by 2.
Exactly right. So we're going to take 2 times row 2, and we're going to put the result in row 2. Okay? So I'm going to basically multiply by 2. So now this becomes, so I'm going to just write the bottom row. 2 times 0 is 0. 2 times 1/2 is 1/2. 2 times -1/2 is -1. 2 times 1 is 2. Okay. All right, so now we're pretty good because we've got a 1 and a 0 and we've got a 1 here. Okay, so now we need to turn this 5/4 into a 0 using the second row. Okay, then our new row 2. So how do I turn this 5/4 into a 0 using this row? What do you guys think?
Times by 5? No.
Would it need
I
to be
think-
negative 5/4?
Yeah, we're going to take negative 5/4 times row 2. We're going to add it to row 1, and we're going to put the result in row 1. Okay? So I'm going to put a negative 5/4 here. So negative 5/4 times 0 is 0. 0 plus 1 is 1. Negative 5/4 plus 5/4 is 0, so that's good. Negative 5/4 times negative 1 is positive 5/4. Positive 5/4 plus 1/4 is 6/4, which is the same thing as 3/2. And negative 5/4 times 2 is negative 10/4. Negative 10/4 is the same thing as negative 5/2. Negative 5/2 plus 0 is negative 5/2. Okay? And so now you can see here, we've got the identity matrix here, and therefore this is a inverse. Okay? Seems like great fun, right? Okay? So that was the hard method. Okay? This is the same method you're going to have to use when you do a 3x3, and we'll do one of those. But I'll bet you money you guys are going to want to do an easy method now, right? Okay, so we're going to do the exact same problem, and we're going to use the easy method. Easy. But it only works for a 2x2. Okay, so I'm going to rewrite the matrix. A equals 4, 5, 2, 3. Okay. Now, in order to do this, I need to teach you a new thing called a determinant. Determinant. Okay. So if I have a matrix that's A, B, C, and D, then the determinant of A is simply AD minus BC. Okay, so that's your definition. So you're going to multiply these two numbers together and you're going to subtract those two numbers. Okay, and so going back to our problem here, the determinant of A in this case, 4 times 3 is
12.
12. We're going to subtract 2 times 5 is
10.
10. So the determinant of A is going to be 2. So whenever you find a determinant, it's just a single number, okay? Now, the easy method says that A inverse equals 1 over the determinant of A times the original matrix. Now, if this is my original matrix A, B, C, D, okay, what we're going to do is we're going to swap places with the A and the D. So this is going to be A, this is going to be D. And with the C and the B, all we're going to do is we're going to make those negative. We're going to keep them in the same place. This will become negative C and negative B. Okay, and so you'll take and you'll multiply 1 over the determinant times your matrix. Okay, so this is the easy method. Okay, and you'll see how easy it is, especially compared to that in just a minute. Okay, so in our case, we know that our determinant is 2. So A inverse is going to equal 1 over 2 times, we're going to swap the 4 and the 3. So that's going to be a 3 and that's going to be a 4. And then we're going to make both of these numbers negative. So -2, -5. Okay. So now I've just got a scalar here. So a inverse becomes 3 halves, -5 halves, -1, and 2. And so you can see that it's exactly the same answer as I got with the hard method. Okay. Does that make sense?
Yeah.
Okay. So I'm sure if you have a 2x2, you're definitely going to want to use the easy method. But now we're going to do a 3x3, and we can't do a 3x3 except with the hard method. So let's do that. Okay. All right. So now in my earlier class, I wrote the problem down wrong and it caused a lot of problems. So especially when you're doing your test,
A lot of problems.
yeah, it did cause a lot of problems. So I'm going to try very hard to write the problem down correctly. Okay. So A is going to equal 1, -2, -4, 2, -3, -6, -3, 6, and 15. And I'm going to double check and make sure I write this down right. 2, -3, -6, -3, 6, and 15. All right, so I have a feeling this is going to go a lot better than it did in my earlier class. Okay. All right, so now if we want to find the inverse matrix, you'll notice I put the dotted line. What am I supposed to put to the right of the dotted line?
1 0 0 1.
1 0 0 0 1 0 0 0 1, the identity matrix, right?
Mm-hmm.
Okay. Now we need to turn the left side to look like what is on the right side. Now the cool thing is I already have a 1 here, which is awesome. Now if I didn't have a 1 here, I can swap rows as needed. Okay. But of course, if I'm swapping rows, I'm going to have to swap this side as well. Okay. So we've got a 1 here, so that's fantastic. So my goal, here, I'll write it down here. My goal is to get a 1, 0, and a 0 in this first column. So how can I get a 1, 0, 0 using row 1?
Did you times it by -2 and then add it to row 2?
Perfect. Okay. So we're going to take -2 times row 1 plus row 2, and we're going to put the result in row 2. Okay. So -2 plus 2 is 0. +4 minus 3. Actually, before I do this, top row is not going to change. So I'm going to write the whole thing out. -2, -4, 1, 0, 0. So top row does not change. Okay. So -2 plus 2 is 0. +4 minus 3 is 1. +8 minus 6 is 2. -2 plus 0 is -2. 0 plus 1 is 1. 0 plus 0 is 0. Okay? All right, so now we need to turn this -3 into a 0 using the first row. How do I do that?
You times it by 3.
By 3. So 3 times row 1 plus row 3, and we're going to put the result in row 3. Okay. All right, so I'm going to erase that and I'm going to put a 3 here, positive. So 3 times 1 is 3. 3 minus 3 is 0. 3 times -2 is -6 plus 6 is 0. 3 times -4 is negative 12 plus 15 is 3. 3 times 1 is 3. 3 plus 0 is 3. 3 times 0 is 0. 0 plus 0 is 0. 3 times 0 is 0. 0 plus 1 is 1. Okay? So this has worked out really well because my first column is great. My second column is really close. I just need to turn that 2 into a 0. So how can I turn that negative 2 into a 0? Using row 2, I guess that's a helpful hint.
You're going to multiply column 2 by positive 2?
Row 2. Yes, that's
Yeah,
exactly
row,
right.
sorry.
So we're going to take 2 times row 2, and we're going to add it to row 1, and we're going to put the result in row 1. Okay? So I think I have enough room here, hopefully. All right. So in this case, 2 times 0 is 0. Actually, my middle row is not going to change. Let me write my middle row down. So 0, 1, 2, negative 2, 1, 0. So the middle row is not going to change. So 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 is 2. 2 minus 2 is 0. 2 times 2 is 4. 4 minus 4 is 0. Oh, we are just lucking out all over the place here. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. 2 times 1 is 2. 2 plus 0 is 2. 2 times 0 is 0. 0 plus 0 is 0. Okay? Now, this is really cool because I just need to get this 3 to become a 1. What's the easiest way to turn that 3 into a 1?
Mm,
Times it by 1/3.
Exactly right, 1/3. Okay, so I'll put this up here. So we're going to take 1/3 times row 3, and we're going to put the result in row 3. Okay. All right, so 1/3 times 0 is 0. 1/3 times 0 is 0. 1/3 times 3 is 1. 1/3 times 3 is 1. 1/3 times 0 is 0. 1/3 times 1 is 1/3. Okay. So this is fantastic because we are almost perfect now. The only thing that is not a 0 that I need to be a 0 is that 2. So how do I turn that 2 into a 0 using row 3?
times row 3 by negative 2, and then add it to row 2.
That's exactly right. So here, I'll just write it here. So we're going to take row 3. We're going to multiply it by negative 2, and we're going to add row 2 there, and we're going to put the result in row 2. Okay, so my bottom row is not going to change. 0, 0, 1, 1, 0, 1/3. My top row is not going to change because I've already got it perfect the way I want it. 1, 0, 0, negative 3, 2, 0. And now we're going to take, here, I put it over here. This is going to be easier if I put it over here. 1/3 times 0 is 0. Okay. 1/3 times 0 is also 0. No, sorry. It is 0, but 1/3 times 0 is 0 plus 1 is 1. 1/3, I'm putting a 1/3 here. I shouldn't be using that. I'm supposed to be using a 2. Sorry, this is a 2. So 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. 0 plus 1 is 1. 2 times, oh, it's going to be a negative 2. Negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Negative 2 times 1 is -2. -2 minus 2 is -4. -2 times 0 is 0. 0 plus 1 is 1. -2 times 1/3 is -2/3. -2/3 plus 1 is -2/3. Okay? So I now have the identity matrix here, and this piece here is a inverse. Okay? That went much smoother this time, Landon, huh?
So much smoother.
All right. Practice makes perfect. All right. So now let me just mention one other thing. Okay? Well, a couple other things, but one other thing that I want to mention. If you are doing these sort of operations, and on the left side you get a 0, 0, 0, that's a big problem. Okay? And you know, over here you'll get whatever you get. Okay? If you get 3 zeros on a row, that means the inverse, or the inverse does not exist. Or another way to say it, the matrix is not invertible. Okay? So so that's something that you could run into on your homework if you get 3 zeros on a row, or all zeros, I should say. It could happen on a 2x2. All zeros on a row, the matrix is not invertible. Okay? All right, now the last thing that I want to talk about is we can solve a system of equations with an inverse matrix. Okay, so before I show you the matrix, let's talk about an equation. So if I have AX equals B, okay, and A and X and B all represent matrices, how would you solve for X?
Would you multiply by 1 over A?
Okay, so it would be nice to multiply by 1 over A, but we can't, but that's really division, and so we cannot do matrix division, okay? But we can use the inverse matrix, okay? Because remember, when I take A inverse, this becomes the identity matrix, and therefore it essentially goes away. Does that make sense? So we can't do division, but we can do inverse matrices, and so essentially that will go away, okay? Now order matters on this, and since I have A inverse in the front, I need A inverse here as well. And so in this case, I'm going to get X equals A inverse times B, okay? Now that's going to become very useful. So let's talk about how we would do that with a system of equations, okay? So let's say that I had a nice little 2x2 matrix here, and I had 2x minus 5y equals 15, and I had 3x minus 6y equals 36. Okay? All right, so what I could do if I wanted to solve this with inverse matrices is I could create a matrix A, which would be simply 2, -5, 3, and -6. Okay? I could also represent a matrix X, which would equal X over Y. And I could also represent B as essentially the solution set, which would be 15 over 36. So remember, we had AX equals B, and we solved that and said, well, X equals A inverse times B. Okay? And I didn't mean to make that look like a fraction. That's not really there, okay? All right, so we're going to use this information. So I need to find the inverse of A. Now, do you guys remember how to use the easy method to find the inverse of A? First of all, we need to find the determinant, right? Who remembers how to find the determinant of A?
Oh, you do 2 times -6.
Which is
Minus.
-12. Minus?
Is it 3 times -5?
Yeah, so it's minus a -15, right? So -12 plus 15 ends up being 3. Okay, so your determinant of A is 3 in this case. So what we're going to do is we're going to take, remember that with the easy method, it's 1/3 times the inverse matrix. And the inverse matrix, we're going to flip places. So this is going to become -6 and 2. And then we're going to flip signs on both of these numbers. So that's going to become -3 and +5. Okay? So that's going to be your A inverse that we've got right here. Now we're going to multiply that by B, which is this matrix here, 15/36. Okay? Now you can see that if I took the 1/3 and I went through here, I'm going to end up with a bunch of fractions and it's going to be ugly. But because scalar multiplication, and 1/3 is a scalar, is commutative, I can take this 1/3 times 15/36, and so 1/3 times 15 is 5, and 1/3 times 36 is 12. I just need to multiply that by -6, 5, -3, and 2. Okay, so I've got a 2 by 2, and I've got a 2 by 1. The middle numbers are the same, so my final matrix is going to be a 2 rows by 1 column. Okay, so now I can multiply these. So -6 times 5 is -30. 5 times 12 is 60. -3 times 5 is -15. 2 times 12 is 24. And so I get my matrix X equals -30 plus 60 is 30. 24 minus 15 is 9. And so that is how you can solve a system of equations with the inverse matrix. How about that?
Why did the 1/3 only apply to the second matrix?
It can apply to either matrix.
But it doesn't have to go to both?
Well, it does, because remember, this is like, think of it this way. This is like the scalar multiple C times A inverse. Well, these two are commutative, so I can take this C times A inverse times A, and that doesn't change, because I mentioned that earlier. Where is it here? Back here, I said the inverse of a matrix is commutative. And so I can change, so the scale, and plus we learned in another section that C is a scalar, and so it doesn't matter whether you multiply by the first or the second. And it just makes it a whole lot easier if the math's easier, because 1/3 goes into these two numbers a lot better than it goes into those 4 numbers.
So you can pick which one it goes into?
Say it again?
You can pick which one it goes into?
You can, because this is a scalar number. This is just a constant, essentially. So you could multiply it by the first one. If you did, you end up with a bunch of fractions, and it just makes it a little bit uglier. But technically, you could. It's just easier to do it that one, because those are both divisible by 3.
Gotcha.
That's why I did that. So, any other questions? No? Is it better the second time, Landon?
Much better.
Cool. Well, if you want to come,
Mostly because it's just it's just going through it twice in a row. It gets more fresh in the brain. It's not so much the teaching.
Right. Okay. All right. Well, Landon's in my 9 a.m. class, and he's been coming this week to both classes. And if you guys want to come to the 9 a.m. class and watch it twice, that's fine with me too. So just make sure you've taken your quiz if you come to the 9 a.m. class. Okay. All right. So the quiz is already up. Quiz on 6.3 is due tomorrow, 5 minutes before class. And we will see you all tomorrow.